What if your dog could actually tell you when they're hungry, anxious, or just not in the mood? Today, we'll ask whether AI could ever let dogs talk, how close we are, what tech is used, and the big technical and ethical roadblocks. First, a quick tour of the science, what AI already does. Researchers can classify different bark types and infer basic emotional states: playful versus aggressive, alert versus stressed. Modern models can even estimate breed, age, or sex from vocalizations using large bark datasets. Surprisingly, human speech self-supervised models adapted to dog audio perform well on these tasks. Think pre-trained speech encoders, repurposed for canine sound patterns, then fine-tuned for dog-specific labels. Now, how would a real dog translator technically work? Step 1. Data capture. Lots of labeled recordings, barks, whines, growls, plus context like behavior, environment, and time of day. Step 2. Representation learning. Self-supervised audio models, Wave 2 Buvec style, learn structure without full labels, then fine-tune for emotions or contexts. Step 3. Multimodal fusion. Combine sound with video of body language, accelerometer data for tail and movement, even heart rate. Step 4. Mapping to human-friendly phrases, short intent labels like "I'm scared," "play," or "food." Important note, this is interpretation of internal state, not a literal translation of grammar. What about brain-computer interfaces? Human BCIs can already decode attempted speech in clinical settings. Astonishing progress. But translating canine brain activity into full language is far harder. Different brain anatomy, likely invasive recording for fidelity, and limited training signals. So while BCIs show a technical pathway, using them for dogs to produce sentences is ethically fraught and scientifically premature. Here are the key challenges, and why talking dogs isn't just an app update. Data and labels. Dogs don't produce language, so we lack ground truth meanings tied to signals. Most data sets capture context, not semantics. Individual variation. Breed, age, size, and personality create huge variability. Models must generalize, or be personalized per dog. Ambiguity. Emotion isn't the same as propositional content. Hungry versus "I want your sandwich" can be conflated. And real-time robustness. Noisy homes, overlapping sounds, and false positives remain real risks. Next, ethics, welfare, and risk. Welfare first. Any wearables must prioritize comfort. Invasive BCIs raise major questions of animal consent and safety. Beware anthropomorphism. Owners might overinterpret outputs, projecting human intent and making poor decisions for the dog. Privacy and commercialization. Pet audio and biometrics are valuable data. We'll need transparent validation and regulation as companies enter the space. So, what's realistic and when? Near term, over the next few years. Tools that classify emotional state or context with confidence scores, 70% playful, 60% alert, already exist in labs. Long-term, decades, uncertain, reliable sentence-level translations or literal dog-to-human speech would require breakthroughs in animal semantics and likely safe neural recording tech. Don't expect literal conversations in the next few years. Here's a quick demo of a future app. Your dog's bark, 84% playful, 12% attention-seeking, 4% alert, likely meaning, "Let's play." That's realistic. A device that prints long sentences on demand? Not yet. Closing thought. AI is already decoding barks and emotions, and multimodal systems will only improve. But turning a dog's full thoughts into human sentences is a much tougher ethical and scientific challenge. Would you use a dog translator app? Tell me in the comments and subscribe if you want a deep dive on animal BCIs next.